Hey.
Hello everyone, I'm Fierra Bogas.
And I'm Trishia Fabian.
And we are the MC Squared. Today we are going to discuss light as a wave. But first, let me ask you a question, Trishia. What comes to your mind when you hear the word light?
When we are young, our ideas about light are just simple. But as the years passed by, our knowledge about light became more deeper. I learned that it is an electromagnetic wave is visible to the eye. Since we've been able to see the sun, that is the start of being aware about light. How about you, Fierra?
I learned that we are surrounded by the electromagnetic waves. It is everywhere. From the light we can see to the infrared our body is producing, to the ultraviolet that coming through the window from the sun. We can never escape the waves.
Is light really a wave? Let's watch this video
so we can know more clearer about light as a wave.
Professor Dave, let's learn about light.
He knows a lot about the science stuff. Professor Dave explains.
Since we've been able to look up at the sun, we've been aware of light. As darkness is one of very few things that we instinctually fear, we have always bestowed light with godlike properties. But for all of antiquity, we had no idea what light really was. Figures like Newton and Huygens worked with light in the 17th century, but a more sophisticated description of light, which we call classical electromagnetism, was developed largely by James Clerk Maxwell in the 19th century. This theory depicts light as a transverse wave composed of oscillating electric and magnetic fields, which are at right angles to each other and perpendicular to the direction that the wave moves. We will learn more about these fields later. Just like the kinds of waves we have previously discussed, electromagnetic waves have amplitudes, wavelengths, and frequencies. But instead of different frequencies producing different pitches, like sound waves, different frequencies of electromagnetic waves produce different kinds of light. If the light is visible, these frequencies will correspond to different colors. Frequencies greater than this will exist as UV radiation, X-rays, or gamma rays, and frequencies less than this qualify as infrared radiation, microwaves, or radio waves.
How do waves behave? Badly? In this video, we're going to look at how light and sound waves behave. Before we start, you should know that waves can be transverse or longitudinal. To learn more about the properties of waves, watch this video first. Transmission, reflection, refraction, diffraction, absorption, and scattering are all typical wave behaviors. Reflection is when waves bounce off an object. Sound waves are reflected by hard, flat surfaces and is why we get echoes. You hear a delay between the original sound and the echo, because the echoed sound waves have to travel twice as far to reach your ears. Smooth surfaces like glass or polished metal reflect light in a regular way, so a reflection can be seen, like a mirror, or seeing your face in a calm pond. Transmission is when waves keep traveling in the same direction through an object, like light through a window. Absorption and reflection often go hand in hand for light waves. White light contains each wavelength, so all the colors of visible light. The color of an object depends on which wavelengths of light it absorbs and which it reflects. White objects reflect all the light that hits them and absorbs none. Black objects reflect none and instead absorb all the light that hits them. A red object absorbs all the wavelengths except the red, which is reflected. And a green object absorbs all the wavelengths except the green, which is reflected.